Hey guys, Mr. Backerberg here. In this video, we're going to look at solving multi-step inequalities. So just like solving an equation can take multiple steps, solving an inequality can also take multiple steps. The steps that we're going to follow are as listed. First thing we're going to look for is any distributive property that we can take care of. Sometimes our problems will have that, sometimes they won't. If they don't have it, we'll just skip that one and move right on to the next one. And step number 2 says that we want to get rid of any addition or subtraction that is happening within our problem. And again, we do that by using inverse operations or opposite operations. And then number 3, we look to get rid of any multiplication or division within our problem. Again, using inverse operations there. Now, we do have to remember that when we're dealing with inequalities, we have to be careful about multiplying or dividing by a negative number. If that happens, we have to remember to flip our inequality symbol around. So as we take a look at this first example, we're going to solve and graph the inequality 3x minus 7 is less than 8. So if we think about our steps, step number 1 said look for any distributive property. This one doesn't have any, so we're going to skip over that, move on to the next step. Next step said look for addition or subtraction that you could get rid of. So I see this minus 7 happening on the left-hand side. To get rid of minus 7, we're going to do the opposite, so we're going to add 7 on both sides. So on the left-hand side, the minus 7 and the plus 7 cancel each other out, leaving me with 3x is less than 15. Now we want to get rid of that 3 that's in front of our x. 3x really means 3 times x. So to get rid of that multiplication, we're going to divide both sides by 3. And that's going to leave me with x is less than 5. So now what I want to do is I want to take that inequality and go to my number line. I always like to put the number that I'm dealing with in the middle. Our numbers get bigger as we move to the right and smaller as we move to the left. Now looking at our inequality, we want numbers that are less than 5. We don't have our equals to line underneath that, so we are going to draw out an open circle at the 5. We want the numbers that are less than 5, so less than means that we're going to do our shading or draw our arrow pointing out to the left-hand side. As we take a look at our next example, we've got 3 times, inside of the parentheses, x minus 5 is less than or equal to 15. Here, step number 1, looking at distributive property. We do have some distributive property to do with that 3, so I'm going to distribute that in. So 3 times x is 3x. 3 times negative 5 is negative 15. And this is less than or equal to 15. We've taken care of the distributive property, so now we look for addition or subtraction to get rid of. I see a minus 15, so to get rid of minus 15, I'm going to add 15 on both sides. So that'll leave me with 3x is less than or equal to 30. I want to get rid of that 3 that's in front of the x. 3x really means 3 times x. So to get rid of that multiplication, we are going to divide both sides by 3. And that's going to leave me with x is less than or equal to 10. Now if I go to my number line, I'm going to put that 10 in the middle. Our numbers get bigger as we move to the right and smaller as we move to the left. Looking at our inequality symbol, it's less than or equal to. So when I go to the 10, I'm going to plot out a filled in circle since we do have that equals to line underneath our inequality. The numbers that are less than 10 are happening on the left-hand side, so I'm going to draw my line or my arrow pointing out to the left. Looking at our third example here, we've got 3 minus x is less than 2x plus 6. The first thing that I notice is that we have variables on both sides of our inequality, and we want to get those on the same side. And we always like to have our variable on the left-hand side if we're able to. So I'm going to look at that 2x, and I want to move that 2x over to the left-hand side. Because it's a positive 2x, I want to subtract 2x on both sides. So that's going to leave me with 3 minus 3x is less than 6. Now, I want to get rid of that 3 on the far left-hand side. That's a positive 3, so we will need to subtract 3 on both sides. That's going to leave me with negative 3x is less than 3. Now, we've got a negative 3x, so that really means negative 3 times x. So we're going to divide both sides by negative 3. Now, we do have to be careful when we do this. We are dividing by a negative number, so we have to remember to flip our inequality symbol around. So this is actually going to say x is greater than Now when we do that division, 3 divided by negative 3, we get negative 1 as our answer. So we get x is greater than negative 1. I'm going to take that negative 1 and put it in the middle on my number line. As we move to the right, the numbers get bigger. And as we move to the left, the numbers get smaller. Now we want x values that are greater than negative 1. We don't have the equals to line, so that means open circle at negative 1. And the numbers that are bigger than negative 1 are heading out to the right-hand side. Now there are a couple of special types of inequalities that we could run into as we're solving things, and I want to show you an example of each one of those. So on this one, we've got the inequality 1 minus 8w is less than or equal to negative 4 times 2w minus 1. So first thing I'm going to tell you is that something weird is going to happen as we're solving this one. We want to look for distributive property, and I see that negative 4 happening outside of the parentheses on the right-hand side. So I'm going to distribute that negative 4 in. So negative 4 times 2w is negative 8w. And then negative 4 times negative 1. When you multiply two negatives together, you get a positive answer, and 4 times 1 is 4. Now we haven't changed anything on the left-hand side yet, so we're just going to leave that as 1 minus 8w, and we have our less than or equal to in there. Now, I notice that we have variables on both sides, so I want to take that negative 8w that's on the right-hand side and move it over to the left. Because it's a negative 8w, we want to add 8w in order to get it to cancel out. Whatever we do to one side, we also have to do to the other side, and that negative 8w and positive 8w end up canceling out as well. So we get an inequality that says 1 is less than or equal to 4. But what I want you to notice is that we get a true inequality on this one. 1 is always less than or equal to 4. 1 is always going to be less than 4, no matter what you do. So what that actually means is if we were to go back up to the original inequality that we were working with, any number that we would plug in for w would always end up giving us a true statement at the very end. So if we're trying to graph out something that's always true, here's what I like to do. I'm going to put 0 in the middle, and as we move out to the right, the numbers get bigger, and as we move to the left, the numbers get smaller. Because this is going to be true for every single value of w, when I graph this out, I'm actually going to draw my line going in both directions and putting an arrow on both sides. That visually means that it's going to be safe for us to plug in any number that we want for that w value, and it will always be true. Now, as we're looking at our last example here, again, I want you to be on the lookout for something weird happening as we go through and solve this one. So we've got 14x plus 5 is less than 7 times 2x minus 3. I see that we've got some distributive property happening, so I'm going to distribute that 7 to the 2x and get 14x. And then when I take the 7 times the negative 3, I get negative 21. Now we haven't done anything on the left-hand side yet, so I'm just going to copy that down. And we've got our less than symbol happening in the middle. We've got variables on both sides, so we want to get them both on the same side, preferably on the left-hand side. So I'm looking at that 14x that's on the right-hand side, and in order to get rid of that positive 14x, we're going to subtract 14x on both sides. Now on the right-hand side, the 14x and the negative 14x, or minus 14x, cancel out. And on the left-hand side, notice the exact same thing is happening. So now we're left with an inequality that says that 5 is less than negative 21. Now, comparing this to what we saw in the previous one, on the previous example, we got something that was always true. On this one, we get something that's never true. 5 is never less than negative 21. So what that means is that no matter what number we would try to plug in for our x in the original inequality, it's never going to work out for us. We're never going to get an actual answer that works. So because this one's not really possible to solve, there isn't really a graph that we can draw out either. So we can say that this one has no solution. That's going to be it for this video. Thanks for watching.